Okay. Okay, nice funding this packed room, because I have only very limited time for 20 minutes. My intention is to present you the underlying technology and provide you 2 demos, hopefully. And much more, I would like to answer questions as well. So I will be a bit theory, but very funny theory. And then let's have some demo and so on. So we are going to see what are multimodal embeddings, vector search concepts, those are returning the results, and the 2 demos I prepared. My name is Marton. I'm from Romania. I'm a software developer. I'm not a Googler. And that means that I'm using Google Cloud, and I actually talk about this technology. I have given, I think, more than 100 talks. I don't count it because it's not a thing for me. I love to talk about technology, and I'm, let's say, developer, not a spokesperson. I make mistakes how I speak, but I want to share all what I do in my life and so on, what I learned about this. I wrote a couple of articles and I answered on Stack Overflow a lot of questions. That's why I was appointed as GDE. My answers were like for 50 million people 10 years ago. And I was, let's say, influencer back then. There was no influencer back then, but I was answering so much that I got the roots for it. Good. Usually, it's hard for programmers to explain what they are presenting. So I used this novel way of presenting technology. Who, what, how it helps. So I try to condense there, like Python developers or everyday developers want to use about new way of search. We are going to talk about Gemini embedding too. There are a lot of other embeddings on the market, but this is focused on this model itself. We are going to present, I'm going to use Google Gen AI as an SDK. It's a one-liner in an information. We need to understand that the dimension, the coordinates, it's 3072. And you need to collect how you are going to use on your day job or on your projects and so on, information, like where you are seeing promising in order to use embeddings and to do, let's say, similarity or identifying similar content, for example, even for a chatbot itself. I think there is a lag there, but essentially it will come up soon. Come on, internet. Good. Gemini 3.6 has been launched yesterday or 2 days ago, something like that. Google did not make a wow factor out of it. They are preparing for 4.0, but it's available on AI Studio if you use it here on AI Studio. And you should not use GeminiGoogle.com. I say this is for my mother, for my parents. AI Studio is for developers. And this is the tool that you need to become familiar, and this is the raw model, not something consumer product, because Gemini is the GeminiGoogle.com is a consumer product. This is the raw model. Usually people don't know about this. So I need to tell to the ROM as well. You have heard about Nano Banana, and we are going to talk about Gemini embedding to wait for it. Okay, I need to wait for it. Good. Traditionally, if I ask the room, everyone knows about SQL. Traditionally, you do exact searches on SQL, where you need to find an item in the database, and most way you understand this concept as tabular data, and that's how, let's say, the legacy search works. But now there are machine learning models that introduce the new way to store information and to actually retrieve information. And we are able to actually do multimodal for inputs where we have text, documents, images, video, audio. They are given as an input to a model, and the model transfers to numbers. Those numbers are called embeddings, and they are pure numbers like on the screen. They are vectors, the 3000 dimensions, and you need to store only that. So the one advantage is that if you add 100 megabytes input, you get only 3072 vector. The size is less, very, very small one, but you get the meaning of the information. This is a true output for the information. Now, this is the core of my presentation, and hopefully you will love this. Essentially, what you see here is that I prepared a coordinate system where there is not x, y, z. There are, let's say, everyday parameters, or the parameters that the model is running and are configured for. This is very simplified. They are just 3 axes here, but it could be 4 billion axes. So think like universe. That's the machine learning today. And if you get an image, and if the image is transformed and put in the space, it gets a cloud of points. It's not a single point, it gets a cloud of points. In multimodality, in embeddings, the concept is that if you get a text, and if you put the same text into the same space, and space like geometric space, not Elon Musk space, geometric space, they are near. And that's the concept of similarity. The model itself can understand that the image and the text are the same. Practical example. Let's say this is an image, this color, and this is the space of the machine learning model. I'm placing somewhere there. If I take a text and I write cola, the cola is not far. It's not here. They are converging there. If I ask him to write cola with different, that comes near this. If I ask him to write cat, oh, that's far, because it's not the same information. If they make a video about the cola, it will come near here. So that's the concept of embeddings. And this is the pure technology about this behind. So where we can use it? Semantic understanding. You are no longer confined to actually invent the right word. Sometimes you say, developers often say, it's in the database, find it. But if you don't know the word, how to find it, the end user doesn't find it. In this technology, they can use their own words. People talk differently, express differently. They can use nuances, like freedom pigeon. Pigeon the animal, I cannot make the pigeon animal. Freedom pigeon, those are the same concepts. Also handling diverse data types, matching the same meaning. It could be find me a picture similar to some input text. It could mean, for example, in customer support tickets, someone is on call or answering tickets, adding inputs, and it's already running a live search. Have we discussed with different words, or have someone had this support case with different words talking about the same stuff, resolving it? I say customer service, but think servicing a Xerox machine. The serviceman working in a Bosch Siemens factory, servicing some items. There are true valuable items and valuable information here to actually be used on this category. Also with specific visual configurations, I will have a demo for this. Aesthetic-driven recommendation. This is the same concept for it. For example, because I usually have women audience and they think and consume different technology, I had to use a different site here in order to be much more appealing for it. For guys, because they don't see it, here there are 3 different images. You see, guys, because you don't see this. So actually there are 4 images on the screen, and they are different. And the technology gives them, and you can find it exactly on the same items and candidate and so on. So this is another practical example. Good. Technical-wise, you need to do 3 steps. The first step is to build the embeddings by using a model. By, for example, choosing Gemini Embedding 2. This is the hosted model on Google. It's a vendor model. You don't need to download it. It's API-based. You need to pay it. I will have a slide about the cost, but they are so minimal that everyone can afford this. And this is the advantage. You don't need a server, you don't need a CPU, GPU, and so on. You just pay the fractional cost to Google for it. And it works like an API, like sending an email. Give me the embeddings, and it returns you the embeddings. Then you have the vectors, and you need to store in a database. 3 years ago, there were not many vector databases. Nowadays, every database you are using, MySQL, Postgres, SQLite, Elasticsearch, Redis, everyone has vector and dense vector struct in order to store this data. The AI will write this code for you like rapidly. When you store in a database, they can be ordered and searched by the database itself. You don't need to figure it out if they are near, because they are providing a cosine similarity function inside the database to group them together. You don't need to invent that. How you search? The user comes with the search input. So here, what the user uploaded or typed in is again added, transmitted to the model on live. It returns the embeddings, and that embedding is the input for the query itself. So that's the called vector search, and you get suggestions, recommendation, results. You get a scored results, like 20 items ranked. It wasn't me, but for me it's good. Ranked items, and you may have choose, like for example, from those 20, I want only the top 5, because those are the relevant. Here, it's an AI technology, so it gives you endless suggestions. You can put a limit, but AI nowadays, you probably understand endless suggestions. So at some point, either you make a decision that it's no longer relevant and you put a score like 0.6, higher, usually numbers are from 0 to 1. 0.6 is a good threshold that I should accept or not elements. Okay, let me see the time, how it moves my time. I have 10 minutes, great. I've shown you this screen, AI Studio, that's how you find it. Good, let me do this demo. Where is my other mouse? I zoom in a bit, and I will be very quick here. So there is Gen AI, which can be imported. You can set here the client for the Google Cloud. I'm on a project, but you can actually grab an API key, and you can use the API key in order to get going with Google Cloud. And this is actually for the full suite of Gemini. It could be the Gemini as we know, it could be NanoBanana, it could be embeddings, it could be anything. It's just the library initialization. In this example, I just put Hello World examples, 4 titles about various items. This is printed in order to follow as a tutorial. Then we are going to use Gemini embedding as a model. We are going to use client, the previous Google client, and they already have a function embed content, and the values are returned. Here you see the values returned for the embeddings itself. These are just numbers and vectors, as you may refer it. In this situation, I define the cosine similarity because I get a question like, how would you do in a raw way? There is always someone asking in the room, how you do this? The answer is use the database provided one, not this one. But if someone wants to figure it out, here is the logical part for it. Then there is the ask, there is the query, what I want to do. And the query here is food. The same query is being sent to embeddings. We get the vector of the query, and then we are sending that to the cosine similarity function as an input parameter in order to, this is your input dot from the space, and I want results near that dot. I simplified dot. It's a cloud of points. but I simplified as a dot. And then you get a list of similarity. And because food was used and food wasn't an exact word, so it's not like burrito, the exact word, it was the meaning of the food, the first result is our success in a way for it. But as I told you, the AI returns you more suggestions. This is very limited example. If you have only one single match, then you cannot detect one single match. You always provide to the user 5, 6. You need to build another system to limit you if you have one single match to cut off the rest of it. But we usually don't do this because in database we don't have singular items. Usually we have many similar items for it. Pretty much this is the technology. It's 3-4 lines of code. Much more important is the technology behind. So we could run like a like statement, but food wasn't in article. In embeddings, we get the meaning of it. And there is a flowchart and so on. Good. Let me run the second example. Let me switch to this image. And let me reload this screen. So I presented the BigQuery version of this talk in Las Vegas at Google Cloud Conference. And there we had to use public, licensed, copyrighted, non-copyrighted material in order to present the demo itself. So we used the Google Landmarks dataset in order to build out the dataset for the concept demo. 100,000 images were compiled into this demo. The embedding size, because you need to store the vector sizes, is 1 gigabyte for it. And there, BigQuery has some concept of lists, like you can use pagination in order to cluster the items. So we use 5,000. And these are random images. And we can run a text search. I have here, for example, let's use this. And until it comes back, because this is a serverless technology and it needs to boot it up a bit, I don't need to put show me into the word, because show me doesn't mean anything into the results. But people ask nowadays this way. In SQL, you cannot put, if you put this in, you run in SQL, you say no results found, because you don't have show me in SQL as a document. But now people are using differently. I often get the question, could I get this information in a different way? Like if I label my images? Yes, I could do that. So it's different thing, but you could do the same thing. But let's see the next query. Find why my mouse is acting strange. Find images with 2 identical objects on it. So you see the shoe. I don't have the pointer, but the red shoe. You see 2 identical objects. Initially, I think in this first image, it made a mistake, but not. There are like 1, 2, 3, 4, 5, I don't know, 16 similar items on it, because the rectangles are similar one, but usually we don't connect to this information, so that's similar as one. And now this is the question, could you do this with labeling? If you pre-label your data? I say no. If you have a researcher and you do an F-sum job, it's congratulations, you can come next year, present the talk. Everyone will be super happy to learn about it. It's really hard to label this kind of information, for example. Machine learning can do this kind of examples. And I have been asked to give much more similar examples about this, which traditional technology cannot answer and so on. And I have just one more here, people working with concrete. And I could ask add the additional queries about these general pictures as well. Come on, internet. You ask for Wi-Fi password, and now my bandwidth is shrinked. No, concrete is a hard material. It comes hard on the internet. So we have people working with concrete. Good. There is the third one, which is I can use different inputs. So far, I use only text input. But I can use, for example, let's see, where is my desktop? AI demo. And let's use, I'm from Romania. You may have heard about Dracula. We have a castle named after Vlad Țepeș. So I use that as an input, and it returns visually similar one. This was the first demo that someone showed to me, and I was blown away. I need this technology because I can use every day in my projects in order to surface these results. Good. Let's go back to this. Let me wait a bit. Yeah, I will do a selfie meanwhile, and then you have a nice room. So where should I stand to have much more people in the room? Can I have your hands up? So they evolved this stuff into understanding much more concepts. So there are like, if you are doing search or question answering, fact checking, code retrieval, classification, you can actually, your inputs need to be created this way. Actually, these are the inputs, and that's the query. You can actually, the input, you can convert this, and more formats appear for it. They are actually doing better in order to organize this in a way for it. For example, code retrieval is a different technology than everyday life, everyday how we talk about it. And it's very helpful for the model itself. Some parameters, the dimensionality, everything is 8,000 tokens. So if you add something super large image, it's getting sized down in a way for it. If you add video, it only does 66 frames per second, and you can even combine things. This is the advantage. So I demoed this table individually, but you can actually create an input where you take an image, you take a text, and as a batch together, you give it to the model. And together, you are actually placing. And then actually you are increasing the model capability and know-how in order to answer better and to organize information for it. Price. So very affordable, like 10 cents to index 1,000 page text to understand the real life exam. 10 cents. For everyone is affordable. I have customers who ask me, oh, it will be thousands. We have, I don't know how many gigabytes of data, and their bill for this is $130. So you need to have massive data in order to make it. The advantage is that you don't need server, you don't need anything, it's just hosted on Google, you just query it as an API. And conclusions, so unified space, I mentioned this, it captures intent beyond exact keywords, affordable, and unlocks e-commerce visual search. You have already seen this. Cross-model media retrieval, you already seen this. Brand and logo monitoring. Suppose you want to check REA on, I don't know, user input image. If you put the input of this image, it will return you similar items. And if it's a match, you found the item. Document RAG. This same technology is being used in chatbots as well, because the citations, which we offer, see only citations and a cool technology, the citations are the results that are surfaced from the database itself. Video content timestamping, you usually see YouTubers, like they can drop in 5-10 minutes and so on. This is also very easy to do with this technology to find the gaps in the change of it. You extract 2 frames, and if it's different, you get the input image, and then you can ask the model to do the timestamping. Good. This concludes my presentation in this short time. I try to show you the basics of the embeddings, and literally this can go in very different domains. I would say in almost any domains where data is being used, and you need to run a search on it. If you have any questions, now is the time. I think I have up to 5 minutes. Yeah. I will be here a bit in the corridor as well, in this popping orange color. So if you want to ask question in the corridor as well, I'm happy to answer as well. But now is the room if someone wants to ask a question. Yes?
If you have a static database.
Hey. If you have a static database, wouldn't it be better to change the images to text first and use that to similarity search than just...
Very great question. An image is only 258 tokens. A single image. You can put in 258 tokens a lot more than text. I was thinking this very differently as you. Text is descriptive. I, human, understood that if I write it down, it's better. No. If I give it a comprehensible image, chart, whatever, it understands the meaning much more easily and in less tokens. You pay less from the same content. So you don't need to take an image, convert in a model, describe what's happening there, toss out the image and embed the text. That's no value into those technology. It's amazing. Yeah, I was there. I was convinced by the fact that this is reversed. But you can put it together, like I mentioned. If you want to keep the image and you have a different human or someone annotates the information with, I don't know, glossary or domain knowledge, because humans use different words for something. Then together they become embeddings because it helps the content.
Even with complex...
Depends on the capabilities of the model. So Gemini embedding 2 is a general model. If you, I don't know, do a research about X-ray images and you put in Gemini embedding, you won't get results because it's general model. It's not for every use case of this building. Let's keep it simple. Next question.
Do we have time?
Yeah, I have a boss here. Yeah, yeah, no time. One more.
Short question, short answer.
Yeah, speak up a bit because you are far from my model.
Sure. How do you handle hash collisions? Suppose you encode your image or text and there's a collision because you have so many symbols that you embed, right?
Yeah.
So how do you handle that?
That's a great question. You may need to eliminate something from the database. That's my answer for it. I don't have a better answer. I've seen on chatbots picking up something from there, and I need to eliminate from the answers in order to stay relevant. Otherwise, it was too detailed, too much for it. That's my answer for it. Other than that, probably another AI model to actually diverse the things in order to span out of the information somehow.